Hello.
Hey, Carson, did you see I got your quiz in? Can you guys hear me? Thumbs up if you can hear me. Okay, all right. There's 17 of us. $14 so far. Let's see if everybody shows up. Well, officially, the time has started, but let's wait 1 or 2 minutes here to make sure give everybody a chance to get in here. $15. Missing 2. I saw Grace. I don't see Kaylin. Quinn. Quinn's here. Dan, I thought I saw Dan, yep. And yep. Ethan. I don't see Ethan. Okay. I think those are the 2. 15, all right, 17. All right, away we go. Let's do this. Hey, everybody. Haven't seen you for a while. I'm glad I can give you some sort of opportunity to go back to normal, at least in a virtual way. So I know that I'm going crazy at home. And I don't know, this is one of the first times I've actually been nervous. I'm a little nervous to see how this goes, and hopefully I give you some good content and give you a good experience here. I'm not going to be dancing around. I'm not wearing pants, so I'm not going to stand up either. But I'm wearing pants. 10, 11, 12, 13, 14, 15. Okay, enough with attendance. We got a test to do. As soon as we're done here, I'm going to open up the test. And I thought a lot about this, and I think I'm just going to open up the whole thing so that If you have an opportunity to do everything today, that's great. If you don't, no big deal. We still have tomorrow for the multiple choice. So officially, today is free response and tomorrow's multiple choice. But if you have an opportunity to get that all done in one session, that's fine. Everybody good with that?
Yeah.
Okay. So once we're done here, I'm going to open up the entire test, and I'm going to open up both of them. I'll have the I'll open them up both on my website and on Google Classroom. No, I actually just want you to go to Google Classroom. Let's just have one place where everyone is turning it in. As you can see, I'm kind of changing my mind as we go. Just like you, this is all new for me. So I'm probably going to have to make decisions on the fly here. All right, here's what I'm going to do. I have you all unmuted right now, but I'm going to mute everybody in case there's a lot of background noise. I just want this to be as quiet for everyone as possible. So I'm going to mute everybody. And let's see, I got the chat here. I'm going to open this up. And let's see, send chat to everyone. If you have questions, just type something in the chat, and I'll look over there every once in a while. And if we have to backtrack, we have to backtrack. All right, so I'm going to mute everybody, and we're going to do a little review. Now, I sent the review. If you have it printed out and you want to play along, that's great, but you certainly don't have to. But this is all preparation for the test. All right, I'm running out of time. Let's get going. Yeah, that's fine. Okay. I need to share my screen. Share, just screen one. Yeah, that's fine. Share. Okay, and you guys are off to the side. Well, no, not in the meeting, no. Here we go. Thumbs up if you see what is the nth term. Okay, all right, here we go. So what is the nth term? We have a sub n is 1/3 plus 1/4 plus 1/5. So a sub n is 1 over, because it's 1 every time on the top. And then this is always 3 more than the index. So this is just going to be n plus 3. And that's it. That's all it wanted. Does the series converge? If yes, what is the sum? There's a couple ways to tackle this. And what I notice is that if you go 1/2, 2/3, 3/4, and 4/5, the terms are approaching a value of 1. And so if you're adding on 1 plus 1 plus 1 plus 1, that's headed off to infinity. That's one way to look at it. Another is, let's say we're starting at n equals 1. Then the top is n and the bottom is n plus 1. So if we have the limit as n approaches infinity of n over n plus 1, that's equal to 1, which is not 0. So this, either way, this is going to diverge. So this diverges, and you could say diverges by the nth term test, but this is mainly for multiple choice here. The next one is geometric, and r is 2/3, which is less than 1. So this converges. So first of all, converges, but then the sum is equal to, and if we plug 0 in, 2/3 to the 0 is 1. So a sub 1 is 1, and r is 2/3. So then we have a sub 1 over 1 minus r. So 1 over, we can multiply everything by 3, I guess. Multiply everything by 3. That gets us 3 over 3 minus 2, because those are going to cancel there. And so we get 3 over 1, which is 3. Find the fraction, a repeating decimal here. Well, the first term would be 0.2. And then we'd have 0.02, and then plus 0.002, and so on in this pattern. Well, this is geometric. And what we're doing is we're really dividing by 10, or really multiplying by 1/10. Multiplying by 1/10. So a sub 1 is 2/10. That's what 0.2 is, which is 1/5. We can leave it as 2/10, actually. That's not a problem. And then r is equal to 1/10, because that's what we're dividing by 10 each time. So the sum is equal to, it's probably easier to leave it as 2/10 actually on this. 1 over, or a sub 1 over 1 minus r, 1/10. So now if you multiply everything by 10, you get 2 over 10 minus 1, which is 2 ninths. So that's the fraction. Find the fraction for this, 2 ninths. Oh, this is so weird with you guys just, you know, muted and silent. Yeah, so let's just keep going. Find the second degree Taylor polynomial for f of x equals 1 over x squared, centered at x equals 3. Find the second degree. So f of 3 is equal to 1/9. You know, you plug 3 in. But this function, remember, is x to the negative 2. So f prime of 3, we're going to take the derivative, negative 2x to the negative 3. And that's negative 2 over x to the third. Now, if we plug 3 in, this can be negative 2 over 27. And then the second degree, remember we're doing second degree, second derivative would be 6x to the negative 4. So that's going to be 6 over 81. What is that? 2 over 27. 2 over 27. So now the second degree polynomial for this is 1/9. And then let's see, minus 2 over 27. Now remember, we're centering this at 3. So x minus 3. And then plus 2 over 27, x minus 3 squared, but then over 2 factorial. Hold on, I want to take a look at something here. Yeah, if I share, I'm not sure I can see any chats, so I don't know. I'm going to try to catch your chat as much as I can. Wonder, let me try this. Let me unmute all, because muting you all being dead silent is very strange. We'll see if we can handle this. And if there's a ton of background noise, I'll just mute you guys again. All right, share again. Here we go. All right, find the first 4 terms of the Maclaurin polynomial 4, and this is in reference to the ones that you have to have memorized. Remember, this is the power series. This is the alternating power series right here. E to the x, all of the derivatives would be e to the x, and if you plug 0 in for all those, it's just 1. Sine, remember, is an odd function. Cosine is an even function. And I don't think I saw natural log or inverse tangent on the test. I'm just going to be honest with you. So find the first 4 terms. Well, let's start out with cosine. Cosine of x is, it's odd, or no, excuse me, it's even. So 1 minus x squared over 2 factorial, x to the 4th over 4 factorial, x to the 6th over 6 factorial. So there we start with cosine. Now remember that it's either replacement or we multiply. So we're going to replace first. So cosine of 3x. We're going to replace all the x's with 3x. 1 minus 9x squared over 2 factorial plus 81x to the 4th over 4 factorial. And then whatever 3 to the 6th is. I think I did it earlier. It's like 729. Yeah, 729. X to the 6th over 6 factorial. Well, now we're going to distribute an x squared through that. So when we distribute, we'd have x squared minus 9x to the 4th, 81x to the 6th, and 729x to the 8th. And then we got to make sure we have the factorials. 2 factorial. There we go. Any questions? Make sure you know those for the test. Find the general term of the Maclaurin series for the given function. So this is in the form of a geometric series, but we need this to be a 1, and we really need this to be a minus. Let's divide everything by 3. So we have 2/3 over 1 plus 1/3 x. So there's dividing everything by 3. But we need that to be a minus. So now a sub 1 is 2/3, and r is negative 1/3 x. So if we wrote a few out, we'd have a sub 1 is 2/3, then minus 2/9 x when we multiply by r, plus 2 over 27x squared, and then this would be minus actually, so and so on. What does it say? The general term. So the general term is we're starting out with 2/3, and oh, we could have 3 to the n plus 1, because that if I start out with 0, then I'd have x to the n. So here's one of the choices. I'm sure there's others for it too. Yeah. Any questions on that? If you're playing along and I'm going too fast, let me know, because I have you all unmuted. Find the interval of convergence and the radius of convergence. The first thing that sticks out to me for this one is it's just simply geometric, because there's nothing strange. Everything is to the n power. Like if you see this one down below, that 2n factorial, that's going to ruin it for geometric. So that means a sub 1 is, if I raise this to the 0 power, is 1. Everything to the 0 is 1. But what we need to know for this one is the r. The r is x minus 2 over 3. That's what we're going to multiply by every time. Well, just, with geometric, we need the absolute value of this to be less than 1. So then we have -1 is less than x minus 2. Recording this is making this writing on my little tablet here, it makes it lag a little bit. Yeah, so -2 over 3 is less than, oh boy, it's getting worse, is less than 1. So -3 is less than x minus 2 is less than 3. It's going to keep me from writing too fast, that's for sure. So there's your radius of convergence. So we already have that. Radius of convergence, no matter what happens now, is equal to 3. But now when we add 2 to everything, we get -1 is less than x is less than 5. Now when this is geometric, if I plug -1 in here, I get -1 minus 2 over 3 to the n. So that's -3 over 3. See, I'm writing too fast. To the n. That's just -1 to the n. And if I go to infinity with that, that's going to diverge. If I plug 5 in here, that's just going to be 3 over 3 to the n. That's going to be 1 to the n. If I add 1 every single time, that's going to diverge also. So here is your interval of convergence right there. And we could write that in interval notation also. But it doesn't matter which one you choose, really. AP will accept either. Everybody good there? How about if we throw in some factorials in here? Now it's not geometric, so we're going to do the ratio test. So the limit as n approaches infinity of the absolute value of x plus 2 to the n over. Now if I plug n plus 1 in there, 2 times n plus 1, we get 2n plus 2. So 2n plus 2. My daughters are kind of loud. It's just how they are. So you probably hear them every once in a while in the background. And then, so it's the n plus 1 divided by the nth term, but of course we're going to multiply by the reciprocal over x plus 2 to the n. Oh, I need n plus 1 here. I forgot the n plus 1. Well, there's an extra x plus 2 up here. Limit as n approaches infinity of x plus 2 over, so now I can write this bottom one down here as 2n factorial, and then write it as 2n plus 1 would be the next number. And then the next number would be 2n plus 2. So that right there, all of those combined is 2n plus 2 factorial. That's kind of the tricky part on this one. So the 2n factorials, they're going to cancel each other, and we're left with 2n plus 1 and 2n plus 2. Well, now if we do the limit on n, infinity is just in the bottom. So we have 1 over infinity times x plus 2. And we want the absolute value of that to be less than 1. Well, 1 over infinity is 0. X plus 2 less than 1. So now no matter what x value you pick, we're going to multiply that times 0, and that's guaranteed to be less than 1. So on this one, the interval of convergence is negative infinity to infinity, and the radius of convergence for this one is infinity. Isn't this exciting, Quinn? And you're probably thinking, boy, we haven't seen this in a long time. And you're right, we haven't. So hopefully you did some of the homework that I posted from last week. And that's still up there. Well, we're going to be taking the test here in a few minutes anyway. So, but quite frankly, I don't know when you're going to take the test. I just need you to have it done over the next 2 days. So if you want to go back and review some of that stuff, you're more than welcome to. I mean, I can't stop you. We're not sitting in a classroom. Okay. Find the interval of convergence and the radius of convergence. Same thing. This is definitely not geometric. The bottom kind of ruins that. So we'll do the ratio test again. So limit as n approaches infinity, x minus 6 to the n plus 1 over. Well, if I plug n plus 1 in there, it's going to be 2n plus 2. So it's going to be 2n plus 5 when we just simplify it a little bit, times 3 plus 2n over x minus 6 to the n. So we have the limit as n approaches infinity of, it's the absolute value of, well, there's just one extra x minus 6. And that's really all we can cancel out on this one, over 2n plus 5. Now, if we do the limit on the n's, it'll be 2 over 2, which is 1. So now we just need the absolute value of x minus 6 has to be less than 1. So negative 1 less than x minus 6 less than 1. And it wants the interval of convergence. Oh, and the radius of convergence. I already know the radius of convergence is 1. So this is centered at 6 with a radius of convergence of 1. So now when we add 6, we get 5 is less than x is less than 7. So far, 5 to 7. Now we have to check the endpoints. So let's plug in 5. And when we do that, we have n equals 0 to infinity. Plug in 5. 5 minus 6 is negative 1. So negative 1 to the n over 3 plus 2n. Now we have to decide whether this series converges or diverges. Well, this is an alternating series. So the first thing we do is we take the limit as n approaches infinity of 1 over 3 plus 2n. And that is equal to 0. So it passes the nth term test. It now has an opportunity to converge. Now we have to be able to make this statement. And we're either confident in this statement or we have to do the derivative. So if we plug n plus 1 in, is that going to be less than 1 over 3 plus 2n? Are we confident in that statement? What do you guys think? Yeah, we're confident in that one because this denominator is definitely going to be bigger, so the fraction is definitely going to be smaller. So now we can say converges by alternating series test. Now, really, you're going to have to do all this work if it's a free response question. If it's a multiple choice, you really just have to convince yourself that it converges at 5 or diverges at 5. So this would be for a free response question, converges by alternating series test. All right, how about plugging in 7? Let's go back up here, plug in 7. We have n equals 0 to, how much time do I have? 37. 0 to infinity of 1 over 3 plus 2n. So I'll do this as if we're going to do this on a free response question. I'm going to compare this, compare to n equals 0 to infinity of 1 over 2n. And we could actually just pick 1 over n. But I could factor the 1/2 out, and this would diverges by harmonic series. Well, now we have to show that the limit as n approaches infinity of 1/3 plus 2n divided by 1/2n, or times 2n over 1, that is equal to 2/2 would be 1. And we say which is what?
Positive and finite.
There you go. Positive and finite. Now, they either diverge together or converge together. So these two are going to diverge together. So diverges by, this is called the limit comparison test. So now we can finally do the interval of convergence. And this converged at 5 and diverges at 7. Yell if you need me to stay there for a minute. Let's see. I only have 6 minutes, so I might be able to get most of these done. I'm going to do this one. I'm going to skip around just a little bit. Let's do this one. What is the sum of the series? If you don't recognize this as geometric, you can always write a little bit or a lot of it out. So this is, if I plug 0 in, I get 1/pi. If I plug 1 in, we get -3/pi squared. If we plug 2 in, that's plus 9/pi to the third. So what is the sum? Well, a sub 1, it is geometric, by the way, because we're multiplying by 1/pi. Oh, no, excuse me, multiplying by 3/pi. So a sub 1 is 1/pi, and r is actually negative 3/pi in this case. So the sum is 1/pi over 1 plus 3/pi, because it'd be minus a negative, making this a plus. Now, if you multiply everything by pi, we get 1/pi plus 3. So there's the sum. Geez, I wonder why I picked that one. What is the interval of convergence? 40. I got 5 minutes. This is actually geometric because there's not much that's really messing this up. Everything is to the nth power. That's geometric. So interval of convergence, well, the radius is x minus 2. So the absolute value of x minus 2 has to be less than 1. So -1 less than x minus 2 less than 1. So this is centered at 2 with a radius of convergence of 1. So we add 2. 1 is less than x is less than 3. So 1 and 3 are 1 unit away from 2, centered at 2. Well, if you plug 1 in, you're just going to get -1 to the n. That's going to diverge because it's going to be 1 plus 1 minus 1 plus 1 minus 1 plus 1. That diverges. If you plug 3 in, you get 1 to the n, and just adding 1 is shooting off to infinity. So that diverges. So the interval of convergence is 1 to 3. I think I'm going to skip this one because I really want to get to this last one. Limit, I purposely put up too many so I could cover as much as possible, show you a little bit, as much practice as possible. That n factorial really ruins the fact that this could be geometric, but it's not. So we have to do the ratio test one more time. A lot of the tests, well, there's going to be a lot of ratio test on your test. AP's really fond of that test. So there's all the n plus 1s except for this one right here. N plus 1, here's 3 to the n over, I got 3 minutes. N factorial, x minus 4 to the n, just n, not n plus 1. I'm trying to go too fast now. Limit, n approaches infinity of All right. This right up here is going to be n factorial times n plus 1. That's still n plus 1 factorial. So now the n factorial is going to cancel. We get n plus 1 times x minus 4 over an extra 3. There's one extra 3. So now if we do the limit on n, it's just going to be infinity. So now we want infinity times x minus 4 over 3 to be less than 1. Well, the only way that's going to happen is if x is equal to 4. That's the only way this is going to be less than 1. Because if you take anything else times infinity, you're going to get infinity. So the radius of convergence is 0 because the interval of convergence is just 4. There's no radius at all there. So when you take the test, you have to decide, do you have n on the top left over and it's going to infinity? Or do you have infinity on the bottom and then now your radius of the whole thing is actually infinite? And we did an example of that back here somewhere. Somewhere we did it. Way back here. Somewhere it's on there. All right. I'm going to stop real quick here. There we go, you guys. Any questions on any of this?
On the test, will we have any questions about Lagrange error?
Yes.
Okay.
For the limit comparison test, if it is positive and finite, so if the one you're comparing to is diverging, and then the first one is like positive and finite, like in the example, it would diverge if it's positive and finite?
If it's not finite or positive, you have to just use a different test.
Okay.
Yep.
But if it is, then you can say it matches with the one you're comparing to.
Correct. It'll either diverge or converge together with the one that you compared it with.
Okay.
Mm-hmm. All right. Well, it's 1:45. Are there any other questions? All right. Great to see you all. I'm going to release it on Google Classroom. Oh, on your iPhone, the app Notes, it'll turn it into a PDF. So I'd like you to turn everything in on your free response. Turn it in as a PDF. If you absolutely cannot get it to work, just go ahead and take a picture. But I want that to be your last resource, your last thing you try. Any questions? All right, great to see you. Go ahead.
Ethan Hansen posted something on the chat just now. I don't think you saw it. I don't know if his
Oh, he is here. Oh, yeah, I see him. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Who's not here? Ellie, Carson. I saw Carson. Jonathan? John Steinecke here? Oh, yeah, there you are. For me. I know I'm keeping you too long now. Connor, Eugene. Is Eugene here?
Tyler's not here.
Oh, there you are.
I don't think Tanner's here either.
Tanner. Yeah, Tanner.
Yeah, Callan's gone.
Kaylin and Tanner. Okay, Kaylin and Tanner. All right, thanks, you guys. I don't want to keep you too much longer. You got to get to your next class. Have a great day. We'll see you on Wednesday.